What up? So today I started working on the electronics part of the project, and I thought I would show you what I got accomplished today. So if you watched any of my other videos with like the T head I'm using in like the servo mouth, that show controller, and I'm put that in quotations that I created is the same premise of what I'm doing on this one, but I came with another idea so I could have multiple shows and not have to reprogram it or switch out a EEPROM if I want to play a new show. And that idea was to use a different kind of MP3 player and let the microcontroller trigger the MP3 player, so when it triggers the MP3 player it actually knows what song it's playing, since the microcontroller is controlling it, and then it can just pull that show data and play that song. So that's what I did this morning. I got this MP3 trigger from sparkfuns. It seems like the only product around, hobbyist level product, that does the job, and it works great. And so I got that hooked up. I was very careful to make sure I didn't, because this is a floating signal, the output isn't tied to ground, so you have to make sure you don't, burn it up. You can burn it up real easily. So, and I've also got this mono amplifier from sparkfuns, which I was a little hesitant about. But with this speaker, the only drawback with this speaker is it's kind of heavy. I was trying to use this speaker since it was light, but with this speaker I get plenty of sound out of this guy, and actually had to turn the volume down some. And then the clock part of the audio, that's why I have my oscilloscope here. First time I had an oscilloscope for this project, so let me play the file again. And since I actually had an oscilloscope, I could actually see what was going on, and I was able to mess around with some values till I got a real nice clock. So this is set at 20 milliseconds per division. So this is 10 hertz. So 10 times a second, it'll pull the microcontroller pin low, and that's how the microcontroller knows that it's in sync. And I started out with the old way I was doing it, and I saw how noisy it was and how it wasn't really pulling it down too well, so I experimented with some values, and I was actually able to totally eliminate a transistor that I was using, which I found was not needed at all. And now using an opto isolator, I can get it to cleanly pull it down to ground. You see, that's ground right there. So 10 times a second it pulls it down to ground, and the microcontroller shouldn't have any problem reading that as an interrupt. So this project's actually kind of going a little faster than I anticipated. I kind of am ahead of myself because I don't know exactly all the functions I'm going to put into this project, as far as how many LEDs I'm going to have and what have you. So I'm going to have to sit down and really think about everything this project is going to do, and then I'll have to start actually drawing up the control system. And I pretty much have all the information I need from this experiment with the microcontroller controlling this. I pretty much have all the information I need to make up a control board. So that's what I did today. See ya.